What is up, 8th grade science? Welcome back. Today we are taking notes and talking about the electromagnetic spectrum. So just before this, we should have watched a video. And in that video, it showed you that the electromagnetic spectrum is just a bunch of different light that changes how it acts and how it behaves based on how long the wavelength is. That's all that matters. The only difference between what heats up your microwave and the light coming out of the light bulbs above you is how long the wavelength is. So today what we really need to focus on is understanding these things called spectrum, and then we're going to have to use those to understand next class how we can prove the Big Bang Theory, which is a theory about the origin of the universe, how everything started. But to understand that, we need to use these things, so that's what we're going to focus on today. All right? We're going to start by filling in the blanks on the left, then we're going to talk about spectral analysis on the right, and we are going to wrap up on the next page doing a little practice with identifying elements inside of spectra. Okay? So we're going to start on the left side. It says, not all light is blank, not all light is visible. I'm going to make my pen a little darker. Not all light is visible. So the light you look out and you see above you, that's visible. But, for instance, X-rays are a form of light. Like if you break your arm and you go in and get an X-ray to see if the bone's broken, you can't see that, but it's still a form of light. So not all light is visible. In fact, most of the light that exists is invisible. I'll switch pen colors again, that's a little too big. Not all light is visible. Most of it actually is invisible. This is because there are different kinds of light, and each type of light has a different wavelength and frequency. These terms are not going to be tested in 8th grade. We're not going to talk about them in 8th grade, but I want you to be introduced to them before 10th grade. Each type of light has a different wavelength and frequency. If that interests you, check out what I just boxed in up top. You will not have to know that, but it's interesting, and if you want to check it out, start thinking about what wavelength means, what frequency means. There are 7 different kinds of light waves, and they're all part of the electromagnetic spectrum. If you need help spelling that, it's on the top of your sheet. All 7 different types of light are on the electromagnetic spectrum. And the kinds of light are as follows. You won't have to know these, but it's really interesting. This is just something I think you should know, okay? So the first is gamma rays. Gamma rays are a really, really strong type of light. They're given off by stars. Can't see them. Absolutely cannot see them. They're super, super powerful. If they ever hit the Earth, we'd be in big trouble. They're a space thing, right? Next up is X-rays. X-rays, they're also invisible. X-rays are used to image your bones. Doctors will send them into your body and it'll bounce back off your bone, and then you can see the bone and you can determine whether or not it's broken. That's what X-rays are used for. Next up, and you might notice as I'm writing these, I'm just going across right here. These are the 7 types right above my arrow. The next up is UV light. UV light is still not visible to human beings, but it affects us more frequently. It's given off by the sun, and it hits us every day. If you ever go outside and you get a sunburn, that is UV light that is causing you to be burned. All right, so now we're getting really, really close. And then you see this tiny section that I just circled with my pen. That is visible light. That's everything you can see. Every color, the entire rainbow, all of that falls inside that tiny section, visible light. All right. Next up is infrared. I actually don't know that much about infrared light. I know that's not visible to the human eye. I know that dogs can see it, but infrared is another type of light. And then the last type of light with the longest wavelength is actually the radio wave, which we might think is kind of weird. We probably don't think of it as light, but radio waves, what they're responsible for doing is transmitting information. So you can turn on your TV, turn on a radio, and that information travels in waves just like light does. Okay? Those are your 7 types. You don't have to know them. I just think it's interesting. Right? Let's keep moving in our notes. The only light that we see is called visible light. This is what we're mostly going to deal with because we can see it. Only light we can see is called visible light. It is a small part of the electromagnetic spectrum. It's not big, y'all. It's not big at all. Very, very small amount of it can be seen, and that represents the entire rainbow. Okay? Stars give off all type of light, from gamma rays to radio waves. The waves from these stars can be analyzed to learn about stars. So that's all we talked about, because what we're going to do now is figure out how we can use these types of waves to determine stuff about the galaxy. This is how scientists study space. We don't actually travel to space to learn about it. We use special types of cameras from Earth called spectroscopes, and that is how we're going to be able to figure out stuff about stars. That's what we're going to get into. All right? So now we're moving into the spectral analysis part. That just means looking at these pictures and figuring out what they can tell us. The spectrum of a star reveals dark lines called absorption lines. So I'm going to switch to white. This is an absorption line. This is an absorption line. This is. All those are absorption lines. And that just means that the star is not giving off that type of light. And scientists know certain things based off what light's coming off of it. You can tell tons of stuff about stars, all right? So different elements have their own lines. It's a big space for you to just write the word lines. Those elements we learn about in chemistry, you can figure out if they're in a star just based off this special type of picture when you use a special telescope to read their light waves. The dark lines in the spectrum are called absorption lines, and they show which elements are present. Okay? I want y'all to pause the video, take a shot at this check for understanding question. It says, if we pointed a spectrometer, that's that special telescope, towards a star, what information can we learn? All right? Pause the video, try and give a few thoughts, and start it back up when you're ready. All right, y'all, now that we are back, I'm hoping you wrote down something like this, okay? The spectrometer can tell us, the spectrometer tells us what stars are made of. All based on those lines. Depending on how those lines show up in a pattern, that tells scientists what stars are made of. And that can be used to study so many things about the galaxy, right? If you need to finish taking these notes, pause, because I'm going to move down, and y'all should flip your packet, because we're going to do a little bit of practice here together. So flip your packet, pause if you need a little more work. So here is a spectrum. It's this big, long image, and it's got these lines that tell you what kind of elements are in the stars, all right? So we're going to do a little mystery spectra activity. Identify the elements in spectra A, B, and C by comparing the bright lines present with the bright lines in the spectra for known elements. So all you do is compare each spectrum for each element and determine if that is inside the mystery spectrum. If it is, the element's present. If the lines don't match up, it's not present, all right? To start off, and kind of as a reminder for myself, y'all can write this. We're only going to do A together, but in A, you're going to have two elements. So 2 of these 4 will be listed on the line. In B, there's going to be 2 elements. But in C, there's going to be 3. Okay, so we're only going to do A, but remember, for B and C, you've got 2 elements and 3 elements. So here's how you use one of these spectrum. I'm going to start down here looking at A. And first thing I do is I scan A until I find a line. So here's my first double line. And make my circle kind of small. Hopefully y'all can see it. There's my first double line. And then I'm going to look upwards, just straight up, and try and figure out which element has that double line. Well, this one's really obvious. The double line's really nice because as I look up, lithium's got nothing there, right? But then the next one does, sodium, right here. Sodium's got the double line. That means that this star contains sodium. You can write that. All right? And then if we keep looking, that's all sodium has, right? That's it. It's just got that double line. So that means there's got to be some other element because we have these 2 lines that we still haven't accounted for. You got to figure out what gives those 2 lines the ability to show up in the spectrum. And if you look up again, just look straight up. Look at that. This one turns out to be super, super easy. Because you look up and you see also, we got lithium. The double lines come from lithium. So you can also add to your line lithium. If you were to take the spectrum of sodium, stack it on top of the spectrum for lithium, you would make spectrum A. Okay. So now you are to do the same thing for B and for C. They're more challenging. They're much more challenging. Some good tips for y'all. Look for the double lines and look for oddly spaced lines. Like for instance, spectrum C, this line's all the way out here by itself. If you look up, there's only one thing in that area. It's very, very easy to tell which element gives that line. When you get over here, things get crazy. So focus on the left side first and then work your way to the right, okay? Now that you are done, you may pause the video, shut your Chromebook, and I want y'all to get working on spectrum B and spectrum C. Awesome job, y'all.